Good morning, class, or afternoon. Actually, it's Friday at 4, so 4:42. I have to go work the football game. Anyway, this is the review for the upcoming quiz for advanced algebra, lessons 1.1 to 1.4. All right? Your quiz is being administered to you next week, the last days of the week. First question, identify whether the following sequence is arithmetic, geometric, or neither. All right, arithmetic, geometric, or neither. If possible, find the common difference D or the common ratio R. So for the first problem, we'll look. We got 2 goes into negative 10, so if it's, and then from negative 10 to negative 50, and from negative 50 to a positive 250. So it doesn't look like we're adding the same number, right? Because to do this, we'd have to add negative 12, and go from negative 10 to negative 50, we would have to add a negative 40. It's not the same number. So it's not arithmetic. The next thing is, are we multiplying by the same number? To go from 2 to negative 10, we have to multiply by negative 5. To go from negative 10 to negative 50, we have to multiply by a positive 5. And you're not multiplying by the same number. So there is no common difference, that's the D, and no common ratio. Okay, that's D. So that's R. Since neither one is true, it's neither. Okay, 1.5 to 2.25, you're adding 0.75. You go from 2.25 to 3, you're adding 0.75. To go from 3 to 3.75, you're also adding 0.75. There is a common difference. D equal to 0.75, thus it's arithmetic. Okay. So you have to look for a common difference and a common ratio. And if neither occurs, like on A, then it's neither arithmetic or geometric sequence. If, like in B, where you have a common difference, it's of 0.75, it's arithmetic. Now, part number 2, a portion of a sequence is shown in the table. The terms continue to grow at the same rate according to the pattern shown. So from number N3 to 4, we go to from 40 to 47, which looks to be adding 7. Then 47 to 54, which looks to be adding 7. It says, find the value of A sub 1. So you got 5, 4, 3, 2, 1. Here's one way. 54, 47, 40. 2 would be 33 because we're subtracting, right? We're subtracting because we're going backwards. Right? We're moving in this direction. Boom, boom, boom. And the last one would be 26. So that tells us the value of A sub 1 is 26. Then it says write an explicit formula for the sequence. Well, this is arithmetic. Because we have a common difference of 7. So since we know a sub 1, to write a formula for an arithmetic sequence, explicit, it would be a sub n equals a sub 1 plus d n minus 1. Notice, again, I got to reemphasize this. That 1, since we're using the first term, that has to be a 1. All right? So a sub 1 is 26, so you can write your answer as a sub n equals 26 plus our d of 7, parentheses, n minus 1. Or, if you wanted to distribute the 7 and combine like terms, you don't have to for your test, but if you wanted to, right? So that would be equal to 26 minus 1 is, or 26 minus 7, I should say. Let's just go back. It'll be 26 plus 7n minus 7. And 26 minus 7 is 19. So you have 19 plus 7n. So that's an explicit formula. You're golden if you just leave it like this. But if you prefer to have it written in more of like a slope-intercept form, you can simplify by distributing the 7, combining like terms to bring it to that. Notice they both will give you the same values. When n is 3, this one right here is 7 times 3 is 21. 21 plus 19 is 40. Likewise, if we plug in 3 here, 3 times minus 1 is 2 times 7 is 14. 14 plus 26 is 40. They both give you the same result. This is the answer. Then it says the pool manager knows that he had to add water to the pool each day because of evaporation. On the first day of summer, he added 50 gallons of water to the pool. He added 52 gallons the second day and 54 gallons the third day. The trend continued after 45 days. How much water did he add to the pool? So you basically have a sequence of numbers added to the pool, volume. He added what was on the first day, he had 50. So the first number in the sequence was 50. Then he added 52. Then he added 54. And then he added, and so forth, right? It would have been 56 and so forth. It looks like he's adding 2 gallons more each day. So the common difference is 2. D is 2. And you know the first term, a sub 1 is 50. You need continue after 40. You want to know what a 45 is. All right. To figure that out, you know that a sub n equals 50 plus 2 times n minus 1. So a sub 45 would be 50 plus 2 times 45 minus 1, which is, what is that? 45 minus 1 is 44, times 2 is 88. So it works out to be 88 plus 50. I should have ran it backwards so I can keep it consistent. It's 50 plus 88. And putting my thinking cap on, 50 plus 88, I believe. 50 plus 80 is 130, so 88 would be 138. So this equals 138. So now we have the formula for the sum of the first n terms. S of 50 is going to equal the average of the first term and the last, 50 plus 138 divided by 2, it's an average. Okay, multiplied by the number of terms. And since it's the first 50, n is 50. Oh. All right, so, no, it's not. After 45 days, so it's not 50. It's not S of 50, it's F of 45, the first 45 terms. Okay, so the first term is 50. The second term is 138. That's what that says. And then we have to multiply it by the number of terms, which is 45. So now use your handy dandy calculator. I will use Desmos because I'm comfortable with it. And you can't use this on the test. We are going to take the first term, which is 50 plus 138. 50 plus 138. 30. Be nice if I typed it in right. Oh, divided by 2, but that's supposed to be 38. Times 45. Well, it looks like it's 4,230. 4,230 gallons. 4,230 gallons. All right. Notice I'm adding the units. All right. Add units if they give you units. That's how much water he added over the course of the 45 days. Then on this one, calculate the sum from I equals 3 to 9 of 5. Write the sum as an expression, as a sum of terms. So you put in, remember this is your start, and this is your finish. So you'll have, you put 3 in, that's your starting value. 5 minus 3 is 2. That's the first term, or term 3. Then you put in 4. 5 minus 4 is 1, and that's the second term. Then you put in, that was 4. Then you put in 5. Okay, t equals 3. I'm sorry. I'm not doing this. I'm not writing the bottom right. This is the third term. This is the fourth term. This is the fifth term, which is 0. This is the sixth term, which is -1. All I'm doing is plugging these I values into this expression. All right, so this is I. This is this value, A sub n, I guess. So 2, 1, 0, -1. We got to go until 9. 7 would be subtract. For I equals 7, 5 minus 7 is -2. 2. The eighth term, 5 minus 8 is -3. The ninth term, the last, is 5 minus 9, which is -4. So the sum of the sum of terms. So the sum would be 2 plus 1 plus 0 plus -1 plus -2 plus -3 plus -4. Which equals, okay, well, they calculate the sum. So I'll try and do this in my head. 2 plus 1 is 3 plus, okay, 2 plus 1 is 3, plus 0 is 3, plus a negative 1 is 2, plus a negative 2 is 0. So we're at 0 now, plus a negative 3 and negative 4, that's negative 7. Okay. So the result is negativo 7. On number 5, the recursive formula given describes a sequence. So a sub 1 is 2, a sub n is 10, times a sub n minus 1. Is the sequence arithmetic, geometric, or neither? It is. This is geometric. Because we have a common ratio. Remember, the common ratio is a number that we're multiplying by, and the number we are multiplying by is presented to us right there. It's the number in front of a sub n minus 1. Common ratio r equal to 10. But the answer is geometric. Okay? Okay. Generate the first 4 terms of the sequence. We already have a sub 1 is 2. A sub 2 would be 20. A sub 3, because I'm multiplying by 10, would be 200. And a sub 4 would be 2,000, because we keep multiplying by 10. Write an explicit formula. Well, we could write a sub n, r, remember the explicit is a sub n equals a sub 1 times r to the n minus 1 power. So it'll be a sub n equals 2, because that's a sub 1, times 10, I guess it's under in parentheses, 10 to the n minus 1 power. Okay. Now we can calculate the 10th, 20th, just by plugging it in and using a calculator. Okay, 6. That's how I roll. Bowling alley charges $3 to rent a pair of shoes. All right. So $3 to rent a pair of shoes, and $5 for each game played. Okay, number of games played. If you played one game, how much would you be charged? Well, you have to rent the shoes. That's $5. No matter how many games you play, you always have to lay down, or excuse me, not $3 for shoes. And then for each game you played, you added $5. So for one game, it would be 3 plus 5, or 8. For 2 games, it would be 3 plus 5 plus 5, which would be 13. For 3, notice you would have 3 plus 5 plus 5 plus 5, which is 18. And then for 4 games, it would be 3 plus 5 4 times, it'll be $23. Okay. Now, that was A. B, write an explicit formula for the cost of playing n games. So the cost of playing n games, A sub n, if you look at this, we're adding 5 each time. So this is arithmetic. So a sub 1 is 8, plus 5, that's a common difference, times n minus 1. And that's the answer. You could have, not that you had to, but you could have simplified this and wrote this in this form. It would be, if you distribute the 5, 8 minus 5 is 3, you would have this simplify. It would be 3 plus 5n. That also works. So either one. I'm happy with it written in this form, the one that I circled. Let's work. I'm all about less work. Now, Ricky's total cost is $53. So how many games did he play? Well, that just means A sub n equals 53. So we say 53 equals 8 plus 5 n minus 1. Subtract 8 from both sides. I mean, this is a linear equation, fairly straightforward. So you subtract 8. 53 minus 8 is, what is that? That's 45, I think. So we get 45 equals 5 parentheses n minus 1. Divide by 5, right? We have to divide by 5. We end up with 9 equals n minus 1, so the number of games played is 10 because he had 1. Now we can check, right? We can plug n equals 10 into this right up here. 10 minus 1 is 9. 5 times 9 is 45, plus 8 is 53. And that's exactly how much they said that you paid for the game. The last question. The first 4 terms of a geometric sequence are shown on the graph. Notice we start at 2, then we jump up to 3, then it looks like 4.5, and then it looks like whatever this is. It's a little bit hard to estimate. It says write a recursive formula. All right, so a sub 1 equals 2, excuse me. Almost said 1. Okay, and then a sub n equals a sub 1, which is 2, times, now we have to figure out what r is. R equals the ratio of, looks like 3, because it's always this term, over that term. So it's 3 halves. So r is 3 halves. So we would write this as 2 times 3 halves to the n minus 1. If you wanted to double check it, you could plug in n equals 1 into this. And, oh, sorry, I'm not doing this right. It's, write recursive. It'll be a sub n minus 1 times r. Sorry, I'm mixing up my forms. Oh my gosh, that's so embarrassing. There's your recursive. A sub 1 is 2. A sub 2, this says a sub 2 would equal a sub 1 times 3 halves. 2 times 3 halves is 3, and that's exactly what's there. And then a sub 3 would equal a sub 2 times 3 halves. Well, a sub 2 was 3. 3 times 3 halves is 9 halves, which is 4.5, which is what this is. So it seems to match. And then it says find the 5th term. So we know a sub 2 is equal to 3. We know a sub 3 is equal to 9 halves, just multiplied by 3 halves. A sub 4 multiplied by 3 halves would be 27 fourths. And then a sub 5 would be 27 fourths times 3 halves would be 81 fourths. So it looks like the 5th term is 81 fourths. 81 fourths is 10.125. I'm sorry, it's not 81 fourths, it's 81 eighths, because 81 eighths is 10.125. So that's the 5th term. And that is your quiz. All right? Watch this, as you watch this video, try to do this before you watch this video. And if you have any weird concerns that, hey, you didn't follow, you can't figure it out, come talk to me, and I'll be more than happy to go over it with you. All right? Your test is the last block period of the week. Okay, bye-bye.